In this tutorial, we're going to talk about UV mapping in Blender. We're going to specifically look at an approach to UV mapping that allows you to establish a specific size for an object and its UV map. UV maps by themselves are abstract. They're unitless. The UV space goes from 0 to 1 along the U and 0 to 1 along the V, but it's an abstract space. But sometimes you want to make sure and set something up relative to an actual size, and that's what we're going to look at today. In order to move along with the UV mapping process, I want to have a bitmap applied to the objects that helps us to see what's going on. So if we select the chair cushion, come down here to the material editor, there is this for UV mapping that I've established, and it basically just has this checkerboard pattern, which we can see on the left. That will just give us kind of a reference for what it is that we want to do. Let's come over here and just assign this to each of the objects. These are all objects that are going to have the leather on them. So the wood parts we're not going to be looking at in this tutorial. Okay, now the next thing that we need to do is come down to the data properties and we can take a look at the UV map. So this is the other thing, is that right now we want to just make sure that we've cleaned out the UV map and we're kind of starting from scratch. So what you can do is just delete it and then start a new UV map. And that is one way of quickly clearing out any data that's there. And so you've basically just created a clean slate to work with. When we take a look at this in shaded mode, you're going to note that we do actually see, even though I've removed any UVs, we do actually see this texture applied to the object. So let's go ahead and go into the UV editor and we'll kind of take a look at what's happening. So I've got the seat selected, and we're going to note that if I come over into the UV editor and I select A, we just see a whole bunch of polygons. When you create a new UV map, it does actually create UV data for the object, but what it does is it takes each polygon and it creates a UV polygon that fits the entire UV space. So it's just basically created this really rudimentary UV data. But we're going to throw all that out and we're going to create UV data that makes sense for us. But the issue here is that we want to create a UV map that has a specific size created for the object and that we can apply to all the objects so that we have consistent texture application across each of the objects. One way of saying this is texel density. We want to have the same texel density for the bitmap, which is the leather, applied to each of the objects. And this is one way of going about that. And this approach is really actually very useful for doing package design where you need to generate a UV map that is specifically related to an actual size of, say, a package design label that you need to apply to the object. So let's do this. Let's work specifically on just this cushion. So I'm going to hit the / key. And I'm going to go into the top view and I'm going to remove perspective. Let's just leave the texture out of this for right now and just go into this basic wireframe view. Now, if we look at this, I'm currently in edit mode. So we want to go back to object mode because I want to create a reference object that establishes the physical size that we want our UV map to be. So I've got the 3D cursor at the center of the universe. I'm going to select the main scene collection, go into, press Shift and A, and we're going to create just a basic plane, and let's set the size. Let's set it to 0.7 meters. So when I back out, you can kind of see what its relationship is size-wise to my chair cushion, which is modeled to the physically correct size of the chair. I'm going to come around and look. It's created it right down there on the 3D cursor's location, just so you get a reference for where it is. Its actual position along the Z-axis isn't really super critical. We could move it a little bit closer, but it's just useful to have it below the object for what it is that we're doing. Okay, so I'm going to come here into the left view and note that the chair cushion itself has this slight angle to it. So we're going to be using a projection mechanism, and we want to make sure that we introduce the least amount of distortion as possible. So if I take this reference plane here, R key to rotate. I want to rotate it so it's generally at about the same angle as that chair cushion. In order to do the projected UVs that we're about to do, we want to align the view to be basically parallel to this plane. And in order to help us kind of understand what we're doing, I'm going to switch the transform orientation to local. And then we want to align the view so it's basically down looking along the local z-axis. So we come to view and then down to align view and align view to active. Now that's kind of a clunky menu to constantly go through. Let's add a quick menu to that. So right click on it, do add to quick favorites. Okay, so that's the Q key. So now if I just click it, then the view has reset itself so it's seeing top as being the local z-axis of the object. So let's just do this for a second. Let's come back over into the left view, and I just want to move that kind of down along the local axis so it's not occluding the object. But now you can see I can press the Q key and go back into top relative to that object, and it puts us back in there. Okay, so I'm going to hold the Shift key, select both of these objects, the seat and the reference object, press the Tab key to go into edit mode, press A key to select everything. Now, this is the important part. When we come over to the UV menu, we can come down and say project from view, but bounds, and then we get a UV map projected. And it's used this square as the bounds. So that's 0.7 meters. I can use that as a reference point for our other objects to maintain the correct texel density with each of our objects. Let's go ahead and leave edit mode, and let's go back into the main scene. And then let's come in here now and go back into edit mode for the cushion. We'll go ahead and unwrap this. Now, the whole point with doing that was that we kind of established this center point as being pretty flat relative to that plane, and that's why we projected it down. We can use those as pinpoints. So when we come back over here, we can select those points in the middle. Let's come over here now and turn on texture preview so we can see this. In fact, you know, I think I want to adjust this texture. Let's come over to shading really quick, and let's just select this UV grid texture, do Control T to establish controls for it, and let's just put a value of 10 there so we can kind of see that smaller on the object. And that'll help us to kind of see the distortion. In fact, I'm going to go even a step. I'm going to go higher. And that'll really help to emphasize the distortion that we see from projected UVs. Okay, so let's come back over into UV edit here. And then with the points pinned over here in the UV mapper, we need to make sure that these are assigned as a pin. And then we select all the UVs, and we just then invoke the unwrap function, and those unwrap relative to those pinned UVs. So those help us to kind of maintain that projection with all the perimeter kind of unwrapping. Let's come over here and remove this image from the background in the UV editor, because that's just sort of annoying at this point. So let's come over and take a look at the fact that we have some distortion going on. And I just want to show you this really quick. This is sort of a minor detail. Let's say in the back that we wanted to have less distortion around the back. And we could come down here and we could sort of isolate the fact that there's this one section right here. Let's come into edge mode here in the UV editor. If I double click this, we've got this edge loop that kind of comes to this fork in the road, and we can see it over right about here. So let's do this. Let's come over here into edge mode in the 3D viewport. I'm going to select that loop that we have right there. Let's go ahead and turn that into a seam. So we'll mark seam. We want to do that on the other side too, so that we have symmetry. So let's do that. We mark seam. Okay, and then we just A key to reselect all of this geometry. Now when I come back in here, A key in the UV editor, and we re-invoke the unwrap, it can unwrap this area and produce just a little bit less distortion. So it's in an area in the back that you're not likely to see, but I just like to demonstrate this because you always have to make a decision when UV mapping between fewer seams and potentially more distortion, or more seams and potentially less distortion. And this is one way that you could kind of deal with that. There's a little bit less distortion in the surrounding polygons because it didn't have to try and close that area up. Okay, so let's do this. Let's come over here and leave edit mode for the cushion. The cushion is basically ready. Let's do the same thing now for the seat back. Let's come over to the seat back component. So these two components we're going to UV map next. Let's come over here into wireframe view and we'll go into the left view. Let's remove perspective and we'll grab this reference plane and let's move this kind of on the back side here. R key to rotate this, and I just want it to be basically aligned with the general orientation of the seat back. Let's go ahead and select all three objects, making sure I'm holding the shift key that we finally selected the plane last. So it's the active Q key, and then we'll reset the view relative to that. So that becomes the top. The local Z axis becomes the top view axis. Tab key and then A key to select everything. And then we come up to UV map and then we do project from view, bounds, and there we have our objects. Tab key leaves edit mode and we'll just select the seat backs. Tab takes us back in. Now we just need to separate this. Let's talk about this for a minute. So Blender's UV mapper is kind of an odd duck in some ways. It's got two basic modes that it separates features between, and some of the features have overlap between the two different modes, and I find it confusing. I'm not a big fan of how they do it, but it is the way that they do it. So in the first mode, which is accessed up here, when you see this little icon that says UV sync selection, when it's turned off, you only see UVs over here when the 3D polygons are selected. So let's go ahead and just see what happens if we select just a single polygon of the front. Let's go into face mode and I select that single polygon. You see, we only see that one right there. If I press Command or Control on the PC L, then we have just these front facing polygons selected and only those UVs are shown. And then I can select all of these UVs and I can just move this down. So we have two objects that are in edit mode, and if I press the A key to reselect all of those, then we can see the UVs for both. When I first started using Blender's UV mapper, I was kind of mystified by that. And if you are in sync mode, it will show you all of the UVs regardless if they're selected over here, and that's the big difference between the two. For right now, we're just going to continue working in this default mode. Let's go ahead and switch over into the shaded view so we can see this texture applied. In fact, I'm going to isolate the view here for these two objects so we can see our texture that's projected onto the object. And if we come over here, let's just turn off viewport overlays for a second. You can kind of see how they're projected and it causes this distortion on the edge. But the other thing to note on the back is you can see that the texture actually is mirrored, and that's because it was projected through the objects and the back side here got backward facing projected normals. That's a quick and easy, dirty way of explaining it. But I'm going to show you how the UV mapper will automatically take care of that for us. So let's come over here and zoom in, and then we'll come over to the UV space and let's find our pinpoints right down the middle. And I'm just sort of arbitrarily selecting the most middle, what I'm calling the spine vertices there. Okay, and then we go ahead and pin those, and then let's select everything we want to unwrap, and then we just do unwrap, and there we go. And you see over here that it righted those UVs. Essentially what it did was it flipped the UVs up here so that they're correctly reading to give us a texture that is not flipped. It just sort of gave that operation to us for free. But now you can see that the UVs are nicely crawling across the surface exactly as we would expect. So let's come in now to the rest of the object. There's a more complex object that we're going to take a look at now. Let's leave edit mode, turn overlays back on, and then go back into the main scene. we have this component right here. Let's make sure I have the material assigned to it. And it's a closed object. The objects that we've been working on so far have been open. They've got these big open areas that make it really easy for the UV mapper to unwrap. But this seat bottom component here only has one area that's open for the wood to go into it, but it's otherwise closed. So we need to add some seams to it in order to unwrap correctly. So let's come into edit mode. I'm going to come over temporarily and just disable subdivision so we get a clear view of the polygon structure. I've got a little bit of overlap there. That's okay. It doesn't show up when subdivision is turned on. We need to apply seams so that we essentially have an outward facing, what you could refer to as the bottom, and then an inward facing set of polygons. And we need to create seams for this to happen. And a logical area to really kind of start is this seam that we see right here. And that's the logical place. So in edge mode, let's make sure we're in edge mode here. Double click this and it'll go all the way around. So if we come over into just a wireframe view right here, that'll go all the way around, which you can see like that. Okay, the yellow line. And then we just come over, right click and do a mark seam. So that's one clear edge that's taken care of that'll allow us to dissociate it. But then, and I'm sorry, I'm jumping back and forth between X-ray and non-X-ray. So you'll just have to get used to that. I just don't want to say it every time I'm about to go into X-ray versus I'm going out of X-ray. That gets annoying. So here, let's select an edge loop here. So I've just done the edge loop, which goes all the way around to the other side because of symmetry. And then there's a little bit of a lip right here. Okay. And I want that to go around. So I'm going to hold the shift key and select there, here, and here. And then I've got to do that on the other side. Okay. And we'll select here. In fact, I can just do an easy select, loop select on that. Okay, and then we do our mark seam, and then we can deselect. So we've essentially told the UV mapper that we have these two regions separated by that seam edge. Now, we need to do the same thing. We want to pre-project UVs. So let's come back into the main scene here, and we need to orient our projection plane relative to the bottom of this, which is sort of our reference angle. So we'll just R key, rotate that until we get that generally matching. It doesn't need to be 100%, just generally. Okay. And then select both of them together, making sure that the plane is the active of the selected. Q key takes us into the top relative to the view, the local top. Okay. Tab key goes into edit mode, A key to select everything. And then, in fact, let's go into isolation mode so we can see those clearly. Then we just come up and do a UV, project from view bounds. And there we have those. Okay, so let's leave edit mode so that we can go back into just editing for the seat component itself. We want to separate the two UV islands for the inside and the outside. And let's do that over here. You see, if I come over here and just select, use the island select function right here, it selects everything because it thinks that they're one closed object. But we can cleverly select the island that we want, either the inside or the outside. So let's say I select the outside here, and then we use the select linked function. By default, it's going to come and do normal. It's just going to look at a normal angle, but we want it to use the seam as the boundary edge. And look at that. It gives us just either the outside or the inside. It either used an open area or the seams that we established, which is great. So I can then take these and move these down. And then if I come over into the 3D environment and do Command or Control I to invert, then there we go with those. So selecting all of them, A key, Now we just come over and find our pinpoints, sort of the pinpoints in the middle like that. And then we do that pin operation, and then we just use the unwrap, but we have to select everything that we want to unwrap, right click, and then unwrap, and there we go. So all of the unwrapping that we've done so far have the correct size relationship, or texel density is another way that you could say it, because we used this reference item of 0.7 meters to establish those pre-projected UVs. And this is a really useful technique if you're going to be generating UVs for, say, a package, and you want to make sure you know what size to extract those UVs into an image editor or illustration package, and you can set that to a specific size because we pre-projected UVs. So I do want to show you, though, that there is this method, but there's also another way of syncing up UVs from multiple objects so that they have the same texel density. So let's leave edit mode here and let's go back into the main environment. So if we select all of these objects that we have just UV mapped, these are the ones that contain the leather, or will have the leather applied to them. I can come over and press the tab key to go into edit mode, and everything is selected, and you can see that they all have this same UV map name assigned to them. So each one has a UV map assigned to it, but as long as they're all named exactly the same, any UV mapping operation will kind of think of them as a unit. So naming UV maps consistently that you want to be associated together is really important. Now, if we came over and let's say that we wanted to pack all of these into the island. So right now we've UV mapped this in a specific way that we can apply the texture onto each object, but these aren't optimized relative to other UV islands. We could select everything and then come down to pack islands, and it would pack all of those together. But one thing that you want to be careful of is that, let me undo this, is that we went through the effort of pre-projecting these so we knew that each of the islands had a relationship, a size relationship to each other. And it will maintain that size relationship, which is another way of saying texel density, when you use that pack islands. Had we not gone to that effort of pre-projecting them to maintain that consistency, you would first want to come over, let's come back up to the UV menu here, and you would want to say average island scale. And that would make sure that each of the islands had the same texel density relative to other UV islands. And then you could pack, so if we said average island scale here, nothing much would change because they were already in relationship to each other in terms of their texel density. And then you could come in and you could apply that pack islands to move everything together, and you could increase the margin a little bit like that and put them together. The benefit of the method, again, that I showed is great for package design where you want to establish UVs within a space that you know is relative to a physical size. So anyway, let's just come back over here. Let's come back into shaded mode, and you can see that the bitmap that's applied still maintains the correct relative scale of the bitmap, what we call texel density, relative to the other objects. So I hope you found this to be a useful UV mapping tutorial.